Okay, hi everyone. So now we're going to look at solving inequalities. It's actually for K9, which is graph solutions to two-step inequalities. You already know how to graph because you've done K1 and K2, hopefully. If not, you need to go do those. And this is just we're going to figure out how to solve an inequality, and then you can just go ahead and graph from there. So let's get rid of this. Okay, so solving inequalities. Solving inequalities. Well, you solve an inequality just like an equation. If you know how to solve an equation, you know how to solve an inequality. Except there are two exceptions. And the first exception is which way the inequality points. That can make a difference. A equals B, B equals A. It doesn't matter when you flip it around. But if A is greater than B, then B is less than A. So it does matter which way the inequality points. We'll look at examples on that. The second example is sometimes you have to flip the sign. Not all the time, but sometimes you do have to flip the sign. So those are the two exceptions, and we'll look more closely at those now. All right, so let's look at the first exception, which is which way the inequality points. Which way the inequality points. So let's see. Oops. These things are really hard to work with. Okay, let's see here. One. Which way the inequality points. All right. So looking at this, what we're going to say is if some number is less than x, if some number is less than x, call it a, then x is greater than that number. This isn't terribly complicated. If a is smaller than x, then x is bigger than a. Okay, if a is smaller than x, then x is bigger than a. So let's look at our example. Let's go ahead and let a equal 5. So what that means is if 5 is less than x, then pause. Hopefully you went ahead and wrote then or thought then x is greater than 5. If 5 is less than x, x is greater than 5. That's what that means. All right, let's look a little bit more closely on that. Another example. Go ahead and say let a equals 5 again. Okay, this time we're going to pick a value for x, and we said that x was bigger than 5 in this case. So what's a number bigger than 5? I don't know, let's pick 7. Any number bigger than 5 will work. So if 5 is less than 7, and it is, then 7 is bigger than 5. Okay? These are true things. 7 is bigger than 5, and 5 is less than 7. Now, why are we doing this? Because if we end up with something in one of our inequalities, and we have something like this, if we have something like this, that's kind of hard to graph. I mean, you could. It's just really more difficult. What you want is you want that variable on the left side and the constant on the right side. And if the variable's pointing, or if the inequality is pointing to the variable, then you want it to be pointing to the variable down here. But in this case, the inequality is eating the variable, so we want it to eat the variable here. All right, it's pointing to the 8. We want it to point to the 8 down here. So it does matter which way the inequality points. So that is the first exception. Okay, so now let's look at the second exception. The second exception is sometimes you have to flip the sign. That's why I said sometimes you have to flip the sign. All right. So when does that happen? Well, let's look at that. So if some number, or if negative x, I'm sorry, if negative x is greater than some number, if negative x is greater than some number, then x, because we can't graph negative x, we have to graph x, then x is less than the opposite of that number, is less than negative of that number. If you flip the sign, you got to flip the if you flip the inequality, you have to flip the sign, is what I'm trying to say. Okay, so let's look at an example. All right, let a equal 4. Okay, let a equal 4. Well, if negative x is greater than a is greater than 4, then x, which is what we can graph, is less than negative 4. So Obviously, we can't graph this negative x, but we can graph the x, so you need to know this right here. All right, so let's look at some actual examples of